Okay, so the final lecture for this chapter, we're going to talk about what causes cancer, and we're going to talk about oncogenes and tumor suppressor proteins. So, cancer is caused by damage to your DNA. Okay. So, mutations that cause proteins to behave differently than in your wild type or normal cells. And DNA mutations can be caused from lots of different mechanisms. There's endogenous damage, which means there's damage due to metabolism, free radicals, due to DNA replication, and there's outside things that can cause cancer. So we talk about environmental causes and lifestyle causes, but it really comes down to, one, your genetics, which we'll talk about in a little bit, and cell division. And not to fear, we have means of repairing DNA damage, and you should learn about this in genetics. I think this is an amazing number. 500,000 DNA modification events per cell per day. Right? So this is just another kind of summary of what causes mutations. So again, spontaneous is an important word when we talk about the Ames test in just a minute. So spontaneous means that sometimes there's issues with DNA replication. Base pairs will spontaneously kind of fall apart. Like I said, in metabolism, there's oxygen free radicals that can cause the bases, the ATGCs, to not look proper or not look correct, and so it interferes with base pairing, which is an issue with DNA replication. There are some physical causes of mutations, especially radiation. So we all know that you have to be careful going out in the sun because the ultraviolet radiation can cause damage to your DNA. And then there's chemical mutagens, which we also call carcinogens. So cancer-causing compounds. And what's interesting is not everything that we take in is automatically, or how should I say this? Not every carcinogen is toxic on its own. Sometimes it happens due to metabolism. So in your liver is a place where foreign molecules, things we didn't use in digestion, for nutrients, go to your liver to become broken down and excreted from the body. And you have a series of enzymes called cytochrome P450. And these are enzymes involved in detoxification. So remember we talked about the smoothie R involved in detoxification. So in the liver, the smoothie R produces a lot of these cytochrome P450 enzymes. Oops, sorry. And those work to reduce and a lot of times put hydroxyl groups onto foreign compounds so that they become water soluble, and you can basically pee them out, get rid of them through your kidneys. What's interesting is that sometimes this detoxification can actually activate a carcinogen. So sometimes by breaking down this foreign substance, we actually cause it to become a toxin to us. Okay. And the reason I bring this up is because the Ames test is a classic way to test if something is a carcinogen. So to determine if a compound is a carcinogen. And the Ames test is based on using a bacteria called Salmonella. And this bacteria is deficient. We call it His minus, means cannot make its own histidine. Just to make sure something didn't turn off here. Can't make its own histidine, which is an amino acid. And without this amino acid, you can't make all your proteins. So Salmonella, this mutant, is defective, and it has to have histidine in order to live on the media when we plate it. So what we do is we take media, and when I'm talking about media, I'm talking about a petri dish that doesn't have that amino acid. And so Salmonella will not, this particular strain of Salmonella will not grow without histidine. So what we're asking, if something is a carcinogen, right, so this is due to a mutation, if we add a carcinogen, can it cause a mutation that reverts or kind of counteracts the His minus mutation to His plus? Okay, this is a plus. So basically what we're saying is you have bacteria with a mutation. If you add a chemical that causes a mutation, carcinogen, can it revert it back? And so now the mutation is basically gone or compensated for. And that's the purpose of the Ames test. So Salmonella His minus is not going to grow on media lacking histidine unless somehow it has counteracted that mutation so that it can produce its own histidine. So what you do is you take the bacteria plus the, gosh darn it, potential carcinogen, and you incubate them for a while, and then you put them on the plate, the media, and see if you get any colonies. So colonies oh my goodness, equals a mutation has happened. So one of the bacteria was mutated, now it can grow on its own. What's really important is this control where you have no mutagen, no carcinogen. Okay. This is to show the level of spontaneous mutations. Okay, these are due again to errors in DNA replication, metabolism. So you're always going to have some level of cells that can spontaneously get these mutations and become His plus. That's your background level. Okay. And you compare the number of colonies with the experimental plate to the control plate. And if there's more colonies in the experimental plate, that means that this chemical that you added caused mutations. So let's look at this a little more. You're really going to have 4 plates. Okay, you're going to have the bacteria by itself, right? And that's for spontaneous mutations. So this is your background level. Okay, and you compare that to the number of colonies you get when you add compound X, which is your potential carcinogen. But then you're also going to have a set of experiments that use rat liver enzyme, right? So this is looking at if the liver enzymes like P450 are going to change that compound X into a carcinogen. Okay, so you really need to have, and your book does not illustrate this well, two sets of plates. Okay, one with just the compound X. Does it cause mutations on its own? One with compound X and rat liver enzyme, which says if after metabolism does compound X cause mutations, right? So again, this is your control for spontaneous background levels, and this is your test. And so in this case, you see that there's 75 colonies when compound X is incubated with the rat liver enzyme and the His bacteria. And all of these have only 5, which are background levels. So yes, in fact, compound X is a carcinogen that becomes a carcinogen after being processed in the liver. Okay. If you had seen a whole bunch of colonies here, you would say compound X is a carcinogen even without being processed in the liver. Okay. And if for some reason you saw a whole bunch of colonies on your controls, right, then you would say, I have messed up this experiment somehow. I need to start again. All right, I'm going to stop there just because I have a feeling my computer is having issues, and then we'll finish up oncogenes and tumor suppressors in the last video.